Welcome to the Explainer. Today we're diving into a really fascinating piece of software engineering that most people would never even realize is complicated. We're going to unpack the GitHub team's journey to build an accessible, multi-terminal safe ASCII animation for the GitHub Copilot CLI. When you think of ASCII art, you probably picture the early internet, right? Simple, static, heavily nostalgic. But as we're about to see, bringing it to life in a modern professional command line interface is anything but simple. Okay, let's dive into this, because this entire massive engineering project we're exploring today, it was all built for just 3 seconds of animation. Yep, exactly 3 seconds. A tiny little entrance banner where a 3D Copilot mascot flies in to reveal the CLI logo. It looks super playful, kind of lightweight, but man, beneath those 3 seconds is a staggering amount of hidden complexity. To put that into perspective, those 3 seconds are made up of roughly 20 individual frames. And the canvas they're working with? It's just an 11 by 78 character area. Now that sounds like a fun weekend project, right? A cute little Easter egg. But the reality of terminal environments turns this tiny footprint into an absolute engineering gauntlet. Now, here's the absolute shocker. Managing those 20 seemingly simple frames, it took around 6,000 lines of TypeScript. Let that sink in for a second. 6,000 lines of code for 3 seconds of ASCII motion. And the wild part is, most of that code isn't even for the visuals themselves. It's dedicated to handling terminal inconsistencies, accessibility constraints, and just creating a maintainable rendering logic that absolutely won't break a developer's workflow. Which naturally leads us to this big question. Why on earth is an ASCII animation one of the hardest UI problems in engineering? It's like the ultimate software design iceberg. What you see is this tiny, cute animation floating up top. But what's lurking below the surface is decades of technical debt, totally fragmented environments, and a complete lack of modern design standards. Section 1, the terminal canvas problem. Or actually, scratch that. It's more like the lack of a canvas problem. To really grasp this first major technical hurdle, just think about how spoiled we are by modern web development. Web browsers give us the document object model, robust design systems, z-indexes, hardware-accelerated rendering, the whole shebang. Terminals? They give you absolutely none of that. They treat output as a literal stream of characters. There are no native frames, there are no sprites, there's no compositor smoothing things out behind the scenes. If you want to animate something, you're manually repainting it using cursor movements and standard output rights, and basically just crossing your fingers that the environment can keep up without flickering. And how do you even tell the terminal to move that cursor or change a color? Well, you use ANSI escape codes. These are wild little sequences of characters, like, /x1b bracket 35m for bright magenta, that tell the terminal how to format the text. But they are incredibly inconsistent. Different terminals interpret them differently, and some older environments, like certain Windows command prompts, actually require extra configuration just to support them at all. You're basically speaking a language where every single terminal replies with its own heady, unpredictable accent. Section 2, the designer's dilemma. Designing for a medium that actively fights back. Enter GitHub brand designer Cameron Foxley. He was tasked with making this banner, and he quickly realized standard animation workflows, like firing up Adobe After Effects, were just totally useless here. He actually tried doing it manually, frame by frame, and as he put it, I wanted something more fun. If this is going to exist, I need to build my own tool. So he pivoted. Using Copilot, Cameron built his own custom frame-by-frame ASCII editor from scratch just to mock up the prototype. A brilliantly necessary step, right? Well, until he hit the color wall. Section 3, the ANSI color chaos. So Cameron's early editor worked great in monochrome, but applying those vibrant Copilot brand colors, it totally opened up Pandora's box. Here's why color in a terminal is an engineering nightmare. Even if a terminal supports 256 colors, you absolutely cannot rely on exact hues. Terminals wildly reinterpret colors based on user themes, high contrast accessibility settings, and OS overrides. So specific hex code for Copilot Blue might look flawless on a designer's Mac, but it could render as a completely illegible dark gray on a user's customized Windows terminal. No way around it. So the crucial point is how the team bypassed this massive limitation. They realized they just couldn't hard-code brand colors. Instead, they adopted a semantic 4-bit palette strategy. Basically, they mapped high-level functional roles, like eyes, goggles, shadow, or border, to basic 4-bit ANSI colors. This means the terminal is allowed to reinterpret those basic colors according to the user's theme, but the contrast and the semantic meaning stay perfectly intact. The logo degrades gracefully, no matter how weirdly the user's terminal is configured. It's honestly a masterclass in graceful degradation for any UI. Section 4. Designing for accessibility first. These human factors and accessibility constraints fundamentally shaped the entire architecture. Because look, when you're building a tool for millions of developers, accessibility is completely non-negotiable. First off, the block letter Copilot logo is technically a graphical object, which means under web content accessibility guidelines, it has strict contrast rules. Second, color meaning has to degrade safely for colorblind users. And perhaps most critically, rapid redraws create massive, overwhelming auditory noise for blind developers using screen readers. The screen reader will literally try to read out every single frame of the changing ASCII characters. It's a mess. The solution they landed on was just brilliant in its restraint. To protect the user experience, the banner animation is strictly an opt-in feature. You have to explicitly turn it on. Furthermore, if the CLI detects it's running in screen reader mode, the animation is entirely skipped. No decorative characters, no motion, zero auditory spam. It just takes you straight to the command prompt. Section 5. Engineering an elegant solution. So to bring Cameron's prototype into the actual CLI codebase, engineer Andy Feller had to utilize Ink. Think of Ink as basically React for the terminal. It uses JSX components and renders them to standard output. It's a real game changer for building static CLI interfaces, but it is absolutely not an animation engine. It doesn't natively handle frame deltas, it doesn't sync with terminal paint cycles, and it definitely doesn't solve screen flickering on its own. And remember, different terminals have massive performance variations. Some throttle fast writes, some have wildly inconsistent cursor repaints, and they all handle buffering differently. Because a CLI must never, ever block a user from doing their actual work, Andy had to engineer the animation as a non-blocking best effort enhancement. So the CLI initializes everything it needs in the background, servers, agents, user setup, while the animation runs, making sure it never slows down your startup time. And this brilliantly illustrates the final pipeline that safely corrals those 6,000 lines of code across all these different emulators. It's an architecture built to scale. Step 1. Store the frames simple, as plain text completely separate from stylistic details. Step 2. Apply the semantic color roles at runtime based on the theme mapping. Step 3. Let Ink handle the timing and the actual rendering to the terminal. It's such a clean, maintainable foundation. And what started as a designer's hack is now paying serious dividends. Cameron's original MVP animation tool, it's now a community-driven open-source app called ASCII Motion. People are already contributing to it. It just goes to show this wasn't just some fun side project. It was a necessary foundation. As CLIs become more powerful and agentic, developers really need reliable, accessible ways to bring richer user interfaces right into the terminal. So I'll leave you with this. Next time you fire up a command line and see a seemingly simple tool, a splash of color, or a tiny animation, how will you appreciate the unseen engineering beneath the surface? From battling ancient terminal constraints to ensuring equitable accessibility, a whole lot of work goes into making sure things look delightfully simple. Thanks for hanging out with me for this explainer, and keep exploring the incredible architecture beneath the tools you use every day.